I'm Ethan Kwan, and today I'm going to be showing you a proof of Heron's formula. Now, what is Heron's formula? Well, Heron's formula looks like this. Now, what does this mean? Well, we're going to prove this formula today. Well, okay, so Heron's formula basically states that if you have a triangle and you have their side lengths are A, B, and C. Then and let's say you define a S for the perimeter of the triangle divided by 2, which means A plus B plus C divided by 2. That's the perimeter of the triangle divided by 2. So if we define an S like this is not the area. The area of this triangle would equal the square root of S times S minus A. Whoops, not S minus S, that would be 0. A times S minus B times S minus C. Right? Okay, so that is Heron's formula. Now we're going to prove this today. Okay, so we know the area of a triangle, right? The area of a triangle, kind of bored with this color. We know the area of a triangle. Area of a triangle is equal to 1 divided by 2 base, right? Base times height. Now switching colors is really a pain here. Okay, so here is our formula, right? That's our formula for the area of a triangle. Now we're trying to prove Heron's formula. So we know the base. Base is just C, right? But what is the height? So the height would be this line right here. From here to here. That'd be the height. So if we want to learn what this is, equals question mark, right? Okay, so that's what we want to know. How do we figure that out? Well, there's a really easy way to figure that out. Well, not really an easy way. It does involve some formulas. It does involve some formulas, but I think you'll get the hang of it. It's actually pretty complicated, and the proof is pretty complicated. So I would not recommend this for just starting off with geometry. I would suggest this for maybe intermediate people who actually want to know, and it's actually pretty hard. So you're gonna have to know a lot of things about math. Anyway, okay, so how do we find that height? This height. Well, we're gonna use Pythagorean theorem. If you don't know what that is, I was just not watching this video. Okay, so if this is the height, we're going to use the Pythagorean theorem because we know A. All right, well, we're supposing we know A. And we know B, or we're supposing we know B, right? Okay, so if we put this here, this length here, as X, let's call that X. Okay, this length right here, let's call that X. Okay, then this length here, that would be C. Oops, I'm still on the line tool. C minus X, right? Because this is C, this is X, right? So if this whole length is C, what is this length? C minus X, because this is C, this is X, so C minus X, so if we get rid of all this, C minus X. So that's actually a pretty neat trick you can use. Okay, so now let's use the Pythagorean theorem to solve for A and B. Well, we know A and B, but anyway. So the first formula is going to be x squared plus h squared, right? H squared, that's what h, right? So h squared is equal to a squared, right? X squared, this length here, h squared, a squared, right? So we have solved this triangle here, right? That's the first triangle. And let's do the other triangle, this tiny triangle right here, the BHC minus x. So that one is also pretty easy. C minus x, right? C minus x squared plus h squared is equal to b squared. Okay, so now we have this. Okay, so now let's solve. So let's use the first formula right here. This formula right there. That formula to solve for h. So let's solve for h by subtracting x squared from both sides. If we do that, we get h squared is equal to a squared minus x squared, right? Now let's substitute h squared into this equation. So h squared is equal to a squared minus x squared. So we can just put that in, right? Okay, so if we put that in, we get c minus x squared, and let's scroll down here, c minus x squared, right, or that's wrong, c minus x, close parentheses, squared, plus h squared, but instead of writing h squared, we know that h squared is equal to a squared minus x squared, right? So we can just put that in right there, right? So if we put a squared minus x squared in for h, we get a squared minus x squared, right? Okay, now, and that is equal to b squared, right? Okay, so now let's solve for c minus x squared. If you know FOIL, and you should, we get, and you don't have to square polynomials, you get c squared minus 2cx plus x squared, right? That's this thing, right? Now what we do is plus a squared minus x squared. Now here's a plus x squared, here's a minus x squared. What do? We cancel, right? So if we cancel this with this, we get the simplified formula, c squared minus 2cx, if you call this simplified, plus a squared equals b squared. Now, let's add 2cx to both sides, plus 2cx. Okay, so then if we do that, we get, you know what, I'll just do it down here. Okay, so c squared, that equals, let's see, so that would be, c. That would be, let's see, okay, that would be c squared, and since we got rid of the minus here, we get plus a squared equals b squared plus 2cx. Now, let's subtract b squared from both sides, because we're trying to solve for x here. So, let's subtract b squared from both sides, minus b squared. We get c squared plus a squared minus b squared is equal to 2cx. Divide both sides by 2c. Divide by 2c. These cancels, and you get c squared plus a squared minus b squared divided by 2c is equal to x, right? Okay, so now we know what x is. Now what we're going to do is we're going to put x into this first formula. Where'd it go? This formula. That one right there. So we know what x is, so we're going to put that in for x to solve for h. Okay. Actually, no, we should put it in this formula because it's already solving for h. So, if we do that, we get, well, the actual equation was h squared plus a squared, not plus, h squared equals a squared minus x squared, I'm pretty sure. Let's see. Where'd it go? Oh, yeah. H squared equals a squared minus x squared. Yep, h squared equals a squared minus x squared. Let's just switch colors arbitrarily. Maybe light green, or kind of green, dark green. Okay, anyway. If we insert what we know for x, which is this, if we insert this formula in here, into x in here, we get h squared is equal to a squared minus, and then this whole stuff. I'll just copy and paste. So it would be h squared equals a squared minus, and then we can just grab our here, copy, paste, and we can just, whoops, yeah, there we go. Or now we can put brackets around that. Oops, wrong tool. Put brackets around, oh, wrong color. Put brackets around, whoops, I copied the x as well. That's not what I wanted. Delete, okay. Okay, that, okay. So now let's take the square root of both sides. Square root of both sides. Now we have, wait a second. Okay, so now we know what h squared is, or h is, right? And, right, so if we just take the square root of both sides, h is equal to the square root of a squared minus c squared plus a squared minus b squared divided by 2c. Now we have that equation. Okay, so since we know what h is, we can put in the formula for a triangle, which is area equals 1 divided by 2 base times height, right? Now base is just c, so we can put in area equals 1 divided by 2 c times the square root of all this stuff up here. So a squared minus c squared plus a squared minus b squared divided by 2c, right? Close parentheses. And that is Heron's formula. Now, that doesn't look like Heron's formula, and I'll tell you why. That is not Heron's formula. So now what we're going to do is we're going to solve this to become Heron's formula. Now, this is the hard part, so bear with me. If you already thought this was hard, well, you haven't seen anything yet. Okay, so if we just scroll down, right? Or actually, let's just do the part 2 over here, and let's just copy this. Copy, and go up here. Okay, paste. Okay, so now we have this. So how do we solve this to become Heron's formula? Now, this is the hard part, so bear with me. Now, actually, the next step is to get 1/2 c under the radical, which might seem a little counterintuitive, but it's one of the best ways. Actually, it's the only way I know. Okay, so if we just why am I substitute? Boom. Okay, so okay, so part 2. Well, if you want to pause right now, then you can stop, and then I'll see you in part 2, which is right now. I'm just gonna start in like 3, 2, 1 now. Okay, so okay, so what happens if we how do we put 1/2 c under the radical? Well, we can turn it into 1/2c is equal to, actually, it's going to be equal to c squared divided by 4, which makes sense because the square root of 4 is 2, right? And if we just move c up here, right, because we can do that, we get c squared, so we get c divided by 2, and then since 2 becomes 4, and then c becomes c squared, because if you take the square root of c squared, nothing happens really, it just becomes c. So these are equivalent. So if we actually I'm gonna write square root as sqrt from now on. Squirt. That's what I call it. Squirt. Squirt of and since c squared divided by 4 is same thing as a radical, we can just multiply these, and then c squared would go under the radical. C squared divided by 4 would go under the radical. Okay, so that means that the square root of c squared divided by 4, and I'm not going to write area right now, I'll do that later, times a squared times, and then all this stuff here, c squared plus a squared minus b squared divided by 2c. Yep. Boom, boom. Yeah, that's... yes, because here x was being squared, so this whole thing should be squared. So this should be squared, and then this should be squared. So that means that this should be squared, which means this should be squared. There we go. I fixed it. Okay. So now we have this formula here. Now let's just scroll down here. Okay. So and this should be minus. Okay. So if we distribute the c squared over 4 here, if we do that, we're simplifying it, I guess. Not really. I'll do yellow. Okay, so that means square root, can you see that? Not really, but okay, whatever. Square root of, if we distribute the c squared, we get c squared a squared divided by 4, because you can just move this up there because we're multiplying it like that, so we can do that. C squared a squared divided by 4 minus c squared divided by 4, right? That's just this here. Too dark. Too bright, I mean. Maybe that. Okay, so since it's c squared divided by 4, and then we're going to multiply here by, well, all this business here. So c squared, c squared minus, no, plus a squared minus b squared divided by 2? Yeah, 2c. And then square that. And then here's the square root. Okay, and I can just change that to this color right there. Okay, there we go. Okay, so nice that I'm color coding it. Okay, so now what we do is we change colors. Okay, so now what we do is we can use this cool law here, or actually let's first of all write this here. Instead of squaring it up here, let's just write this as this thing squared times this thing squared. And we can do that, right? Okay, so that thing squared, this squared, and this squared, right? Okay. So now what we can do is we can cancel this with, actually one sec. Okay, let me just write this a little more neat, or actually let me just do it under here. So square root of c squared a squared divided by 4 minus c squared divided by 4 times, and then instead of this big bracket, we're going to do 2 brackets, right? So we're going to do one up here, c squared a squared minus b squared squared, and 2c squared. 2c squared is 4c squared, right? If it's 2c squared, that's going to be the same thing as if we distribute this 2, it's going to be 2 squared times c squared, which is going to be 4c squared, right? Okay, so that's why that happens. And then now what we can do is we can cancel c squared here with c squared here, right? And also we can, and that means we can also multiply this 4 with this 4 here, because that didn't cancel. So 4 times 4 is 4 squared, and I'll explain why I'm not writing, one sec. So squirt of c squared a squared divided by 4 minus, and actually this would be 1 now. So so we just have to write c squared a squared plus a squared minus b squared squared divided by and actually we're gonna combine here, so we're gonna, oh wait, no. Actually, yeah, so if we divide by 4, right? Okay. And, okay, so this is going to be 4 squared here. And so close the big bracket. Okay, so now we can just take this thing here, and instead of doing this, we can just put it up here and get rid of this guy, right? Okay, so if we do that, if we do that, and then if we take this 2 up here and take this 2 up here and take this and take the square root of it, so then we get squirt of CA divided by 2 squared, and this whole thing squared, so like this, right? And then we we subtract that, and we put, let's see, c squared a squared plus a squared minus b squared divided by 4 squared, and take the square root of that. Okay, so now we can use this cool property of square squared, squared squared. That's what I call it. Anyway, so the squared squared law means that x squared minus y squared equals x plus y times x minus y. Now that we can use, and we're going to use that over and over and over again. Well, twice technically, but okay, this is the first time using it. Okay, so if we use this law for here, if this guy here is x squared, right? That's x squared minus, and if this whole thing is y, and it's y squared, right? Then we can put that into x plus y times x minus y. There we go. Of course, no one writes times these days. I'm just gonna do a dot. Big dot. No. Yeah, I'm just gonna do a little dot there. Okay, so if we do that, we can get, well, it kind of simplifies. And I'm just gonna change color, something dark so you can see. Okay, and I'm just gonna scroll over here. Squirt of, and this is halfway done, I promise. We're almost done. Well, we're not really. We're like halfway done, I promise. Okay, so now if this is getting boring, you can just speed this up. So if we do this, we get CA divided by 2 squared, right? And no, wait, no squared, because we got rid of the squared here, right? So it said x squared, no squares in here. And then that. Actually, we don't even need the brackets. Okay, we need a big bracket, fine. We need this bracket here, right? So C squared, CA divided by 2, sorry, I'm just, sorry, if you make a video for too long, it's kind of hard to know what you're doing. C squared plus A squared minus B squared, divided by 4, right? Because this time it's plus, next time it's going to be minus. And then if we just, yep. And then now we're going to do this bracket here, times, and I hope we don't run out of space. Okay, I'm just going to zoom out like that. CA squared divided by 2, okay, no squareds. CA divided by 2. It's minus, but I'm going to do plus, and then take up everything up here and do the reverse of that. So that's going to be, that looks like O squared. I meant C. So C, so it's going to be negative C, of course. So negative C squared minus A squared plus B squared, because we just took the reverse of this, because it is minus, right? But it's the same thing as just distributing this minus, so I'm just going to distribute it, so it's basically the opposite. Divided by 4. And we have that, and then the big bracket. There we go, okay. So I promise we're almost done, okay? Okay, so, if we actually, let's convert this here. Let's convert CA squared here into 2CA divided by 4. So we can add these fractions. So we get, and same thing over here, 2CA divided by 4. Okay, so if we do that, we get, let's see, I'll do dark green. Squirt of, and if we just add these fractions here, and this is not plus or minus, it's just plus, I just underlined it. So 2CA, So we can just add this however we like. So, and these numerators are going to stay the same. They're just going to combine. C squared, and I'm just going to add it like this, plus 2CA, because it's addition, so it doesn't really matter what order you do it in, plus A squared divided by, whoops, too far. Sorry, I just like things to be precise. Okay, 4, or nice looking, at least. And here's that bracket there. And then we're gonna, and then minus B squared, times, and then here we can just add these fractions again. So this is 4 here. Minus C squared, and then we're going to add this, plus, yeah, so, one sec, I'm trying to think of it. No, since this is addition, we're going to move this all the way over to here, okay? So the B squared is going to move all the way over to here, so it's going to be B squared, and then it's going to be minus C squared, plus 2CA minus, is that right? No. Wait. Yeah, this is minus A squared, and we're going to put that in brackets. Okay, so now if we distribute this minus here, yeah. Actually, no, let's not do that. Okay, so, and divide that by 4, we get this. And, okay, so, now what we can do is, well, take a look at this. Okay, so, take a look at this little this section here. Does it remind you of anything? And then take a look at this section here. Does that remind you of anything? Well, I can see a pretty nice pattern here. I can see that this thing here, this is going to be the same thing as C minus A, and then put brackets around that, squared. And I can see that this here is going to be equal to C plus A squared. Okay, so now we can simplify it too. And let's just scroll down here. Squirt of square root of, one sec, that's kind of messy. Square root of C plus A squared, right? And if we just put that in brackets, minus B squared divided by 4 times, I'm going to put a big bracket there, B squared minus, and minus, yeah, that makes sense. Minus C minus A squared, right? Okay, and divide that by 4. There we go. Okay, so now we simplified this pretty well. I'm just going to zoom in again. We have simplified this pretty well. Okay, so now let's use that feature again. Remember? Remember that feature of, remember this? Remember, now we're going to use this a lot, like I told you. So this is the second time using it. X squared minus y squared equals x plus y times x minus y. So that is what we're going to use again. If we think of this up here, if we consider that x squared, and if we consider b squared here, y squared, And same thing over here, if we consider this x squared, and if this is y squared, if we do that, we get squirt of, oops, not equals, that's wrong. Okay, squirt of, and if we do this thing again, so if this is x here, we get, well, we can get c plus a, and then here's going to be y, so y is b, so plus b here, right? Because it's plus b, no minus, right? Times c plus a minus b, because this time it's minus, right? This time it's plus, right? So that divided by 4 times b plus c minus a, right? C minus a right there. And we don't even have to include the brackets. And we're going to divide all this by 4. Put a little bracket there. And b minus c minus a. There we go. Okay, so now we have this. So now we can simplify, and we are literally at the home stretch here. Okay, so let's turn this 4 into a 2 times 2. And let's turn this 4 into a 2 times 2, and you'll understand why I'm doing this in a little bit. Okay, so now let's separate these fractions. And I'm going to have to zoom out here. And just going to change the color here. Okay, so now we can squirt of, and let's separate these fractions. And that's a little big squirt, so I'm going to shorten squirt of, and then, okay, so c plus a plus b, we can rearrange that to a plus b plus c, and then if we separate this here, we get a plus b plus c divided by 2, so a plus b plus c divided by 2. Okay, times, here we can also do that same thing, but look, we can simplify this to a plus b plus c minus 2b, right? A plus b plus c minus 2b. If that doesn't make sense, well, here's the explanation. Okay, so here's our a, here's our b, here's our c, here's our b, but since it's a positive b, we have to subtract 2b, because if you have 1 of something, and then you subtract 2 of it, you get minus 1, right? So that's why that makes sense. Okay? And then, so then we get a plus b plus c divided by 2 minus 2b divided by 2. And we can do that because if we just put the minus here, then we get, oops, that's a very bad minus. Okay, that's the minus. If we put that minus there, that makes sense because we can just separate the denominator. And same thing here, same logic. This here is going to be, well, if we just separate this, same logic. We can simplify this to a plus b plus c minus 2a, right? Okay, and divide by 2, of course. So we can do that right now. Squirt of a plus b plus c divided by 2 minus 2a divided by 2. And I think you can see the pattern emerging. Okay, last term, b plus c and b minus c minus a can be simplified to a plus b plus c minus 2c. And we can divide this by 2 and divide this by 2. And we can do that. Okay, so now we have all the terms. Now, what can we do? Well, we can, since this is that, we can cancel out this 2 and that 2. We can cancel out this 2 and that 2. We can cancel this and that. Okay, so now we can actually see, what's it called? Oh, great. Totally forgot Heron's formula. Okay, so now we can actually see Heron's formula emerging. We can take the square root and, okay. So if we set just a arbitrary variable named s and call it a plus b plus c divided by 2, our equation simplifies a lot. So we can just do squirt of, actually, now what we can do is we can actually put the square root sign. Okay? So a plus b plus c divided by 2, that's s. So we can just put s here. A plus b plus c divided by 2, that's also s. S, but there's a minus b. Minus b, right? Because these canceled, so you only have a b left. Here, we have an s again, right? This is s. And here we have an a, minus a. And lastly, here we have a plus b plus c, which is divided by 2, which is s, minus c. So now we have that. What happened there? Okay, so now if we rearrange this, because we can, because it's multiplication, we get, and drum roll please, area equals square root of s, not a, sorry, keep drum rolling, s times s minus a times s minus b times s minus c. Whew! That was a complicated, I told you, that was a complicated proof of Heron's formula. That is one of the most complicated things I have ever learned to prove. For example, Heron's formula. But aren't you glad we proved it eventually? Maybe you're following along, maybe you're not, maybe you're just bored. Now is the time to show off. And by the way, if you want to know, if you want to see if Heron's formula actually works, let's say we have a triangle with sides, I don't know, 2, 5, and 6. Now what's the area? Well, we can just do s. S is equal to, and since we've been dealing with arbitrary variables, it's nice to have actual numbers for once. S is equal to a, 2, plus 5, plus 6, divided by 2. 2 plus 5 is 7, plus 6. Actually, let's do 2 plus, I don't know, actually let's do 1. 1 plus 5 is 6, plus 6 is 12. Divided by 2 is 6. Okay, so s is equal to 6. So if s is equal to 6, what's the square root of 6 minus 1 times 6 minus b, which is 5, and 6 minus times 6 minus 6. Actually, okay, so this triangle is very weird. So 6 minus 1, since this is a 0, this is all going to be 0. Weird. Okay, I've actually never seen this before. Okay, so if we have this, why does that make sense? Why is the area here 0? That doesn't make 1, 5, 1, a triangle 1 by 5. Oh, so 1 would look like this. 5 would look like this. and 6 would look like that. Yeah, that makes sense. Oh wait, 6. Oh wait, no, this would be a flat line, right? Because 1 plus 5 here, it'd be flat line. That would be the 1, and that would be the 5. Okay, let's try another triangle. Ah, that's a flat triangle. That's what I call it. Anyway, let's have a triangle with sides length, I don't know, 4, 2, and, actually let's do 4, 6, and 10. Okay? Actually, that would be a 0 triangle as well. Let's do, 4, 6, and 8. Okay, there we go. That's a right triangle. That's a nice triangle. Okay, it's not a right triangle. Okay, so if S, okay, what is S? S is 4 plus 6 plus 8, divided by 2. So what's 4 plus 6? 10, 18. So the S is equal to 9. Okay, so the square root of S, 9. So square root of 9 times 9 minus A, 4, times 9 minus 6 times 9 minus 8. Okay, so now we have our equation and square root of that. Okay, so 9 minus 4 is, actually 9 minus 8 is 1 here, so that's not gonna change the value. So 9 minus 6 is 3, and 9 minus 4 is, let's see, 9 minus 4 is 5, and this is 9. 9 times 5 times 3, I'm just gonna use the calculator because I'm lazy. 9 times 5 times 3 is 135. So 135, 135. Okay, so what's the square root of 135? Well, we can simplify that to, let's see, what can we simplify? Is it a multiple of 25? Is it a multiple of any square? Well, let's test if it 135 divided by 25 is not. So actually we have to just leave it as 135. Actually, we can just go online and check if it's a square root simplifier. There it is. Square root simplifier. Come on. Simplify 135. 5. Yeah, 135. 3/15. Okay, that's fine. Wait, 3? Oh, it's a multiple of 9, of course. Yeah, that makes sense. Okay, that was dumb. Okay, so this is 3 times root 15. Perfect. So now we have Heron's formula as another item of our math toolkit. Thank you for watching. I hope you learned something. If you didn't, that would be my fault. Here's all the math we did today. Whew, looking back at it, it looks like a lot. So thank you for watching. I really love making these videos. I think you should too. These videos are really helpful to me, and I hope you learn this too. This video was made possible, or I learned it from Khan Academy. So Khan Academy is a great website where you can just like explore. You can also go look at my YouTube channel and look up Khan Academy, and then and then there's a video about a review on Khan Academy, so that might be helpful. But anyway, that's where I learned this from. Also, otherwise, thank you for watching. See you at howtodosophreezing.com, and see you next time. Bye. Ooh, too small. Bye. I'm just gonna erase all my work. Oh no. Oh man, I worked so hard on that. Why am I erasing it? I'm not sure. I can always undo. Bye. Okay, I'm just gonna, yeah. Okay, bye. Finally. Oh, wait a second. Okay. Oh, there we go. Okay, bye.